This video is on the objective solve trigonometric equations using a calculator. Alright, so in these are going to be linear trigonometric equations. So we're going to isolate the trig function, get the trig function alone on one side and a number on the other. But this time the number on the other side isn't going to be very nice. It's not going to be like a half or square root of 2 over 2 or square root of 3 over 2 or 1 or 0 or stuff like that. It's going to be some not so nice number. So to find one of the solutions, we're going to have to use the calculator, and then we'll go about how to find all the solutions, right? Because remember, if a lot of these trigonometric equations, if they have one solution, they're going to have infinitely many by using coterminal angles. All right, so let's take a look. Again, if you want to see how they're instructing you, click on more instruction, look at their videos, their notes, their examples. Hopefully those help you. So here, this equation, we have the sine of theta plus 0.755, right? See, a not so nice number equals 0. And they're asking us to find the solutions, but only in the range from 0 to 2 pi. Right. So I'm going to go to a piece of paper and write this out. All right, so our equation here is the sine of theta equals, plus 0.755 equals 0. So just like before, I'm going to isolate the trig function. So I would subtract 0.755 here, and that's all that needs to be done to get the sine alone. So the sine of theta equals negative 0.755. Now, as I mentioned, this number over here, now that we've isolated the trig function like we're used to doing, this number over here, negative 0.755, this is not a nice number. Not a nice number. Like I said before, it's not like a half or square root of 3 over 2 or something that some angles with the sine of. So if that's the case, we're going to use the calculator to find one solution. Now, they did want the solutions in radians, so I'm going to go to radian mode. So I'm pulling up the calculator now, and I'm going to make sure that I am in radian mode, and I am. Okay, I'm going to hit the mode button. Okay, so one solution, right, again, just one solution to this would be to take the inverse sine, right, because it's the sine. You can take the inverse sine and get a solution to this. One solution to this equation is the following. Theta equals the inverse sine of this number, negative 0.755, right? This is just taking the inverse of both sides. And let's see what that is on the calculator here. Right, what's the inverse sine of negative 0.755? All right, so this is approximately, looks like all my solution choices in the answers are going to be the 3 decimal places. So I'll round this to 3 decimal places. Negative 0.856. Again, this is in radians. All right, this is in radians. Now what I'm going to do here is I'm going to draw this angle. So here's like the unit circle. Okay, I'll draw here's the unit circle. Drawn really quickly. All right, just a circle with a radius of 1, centered at the origin. So there's 1 up here, negative 1 over here, negative 1 down here. Now, negative 0.856 radians. That's down here in quadrant 4. Right, here's negative 0.856 radians. Okay, there's your inverse sine of negative 0.755 angle. Okay. And if you recall, remember sine was related to the y coordinate of the point on the unit circle. So that means this point here has a y coordinate of negative 0.755, right? So this point here has a y coordinate of negative 0.755. Sorry if that's tiny. So that means, like, so again, one solution is this. Now, what I can do to find other solutions, remember, is once you have one solution, you can just keep adding 2 pi and subtracting 2 pi. So I'm going to start on another piece of paper. I'm going to start writing out the general solution. The way I have been in previous videos, right? So I take this one solution, this inverse sine of negative 0.755, and you can just keep adding multiples of 2 pi to this, right? And get more solutions, because if you add 2 pi, subtract 2 pi, right, you land back at the same place, right? You have a coterminal angle, and it should have the same value, the same sign of negative 0.755. And I'll show you that in the calculator in a second. Now that's not the only one, right? This is not the only point with that y coordinate on the unit circle. Right? There's also this point over here on the unit circle. So what would this angle be? Right? Now this angle has the same reference angle as our inverse sine over here, right? This measure here that I just highlighted and this measure here should be the same measure, right? As they take you down to the same, points with the same y coordinate, this negative 0.755. So, if I want to find, what's this angle, if I, again, start from the positive x-axis, what's this angle here that lands me at a point with the same y coordinate, with this negative 0.755 y coordinate? All right. So we know that this much is pi, right? We know halfway around, and I go from here to here, I know that much is pi radians, and then we know from here to here should be it's again, I'm going in the positive direction now. So then from here to here should be positive 0.856, right? Positive 0.856, which is the opposite. I'm calling it positive because I'm going in the counterclockwise direction. So another solution to this, another angle, and I'll show you in the calculator, would be pi, right? Pi plus 0.856, which is the opposite of this inverse sine. So pi minus this inverse sine of negative 0.755. Right, there's another solution, and I'll show you. Right, here, let me go to the calculator. If I take pi minus this previous answer, right? See, that'd be pi minus this inverse sine. I'm getting 3.997 radians. And look at what the sine of this angle is. Right? The sine of 3.997 radians is, say, negative 0.755. So this is that other angle I drew here. But there should be two of them, right? There are 2 points on the unit circle with that y coordinate, since we're talking sine. All right, and then I could take this angle and add on any multiple of 2 pi I wish. Just keep adding 2 pi subtracting 2 pi, and it'll give me another angle whose sine is negative 0.755. And again, k is an integer here when I see the word letter k. K is some integer. Alright, so what I'm going to do is I'm going to, like I've been doing before, here's the general solution. Here, this is a description right here of all infinitely many solutions to this equation. And what I'm going to do is I'm just going to list a bunch. All right. For different values of k. All right. So again, when k equals 0, when k equals 1, when k equals 2, when k equals negative 1, k equals negative 2, so on. Now when k equals 0, I'm getting these values. Right? Now again, the inverse sine of negative 0.755 was negative 0.856. So this is one solution rounded to 3 decimal places. And then this other one we saw in my calculator already. That's this pi minus the inverse sine of negative 0.75, the 3.997. So here's another solution to this equation rounded to 3 decimal places. And then what I'm going to do with these is keep adding 2 pi or subtracting 2 pi. So I'll do it at the top row here, negative 0.856. So I'm going to take my, go back to it, let's clear it. I'm going to take that inverse sine of negative 0.755, right, which is the negative 0.856. I'm just going to keep adding 2 pi and then subtracting 2 pi later, right? So if I add 2 pi, another solution to this equation is 5.428 if I round to 2 decimal places, 3 decimal places. Add another 2 pi. So that'll be when k equals 2. So another solution is 11.711 radians, and so on. Right? I could do that forever that way. Also, again, if I take the inverse sine of negative 0.755, take that negative 0.856, if I subtract 2 pi, I'll get another solution. Right? So another solution would be negative 7.139 rounded to 3 decimal places. And I'm going to stop there with that line. But I could do that forever. All right. And then I'll do the same thing for the 3.997. Right. So again, that was pi minus that inverse sine of negative 0.755. All right, the 3.997, and then I'm going to do the same thing. Add 2 pi, subtract 2 pi. If I add 2 pi to this will give me another solution. 10.28280. All right. And again, I could go that way forever, subtract 2 pi. I'm going to stop there. Here's 6 solutions to the equation. All right. Here are 6 solutions to this equation rounded to 3 decimal places. And let me show you that this one here, 10.280, that's on my calculator right now, this is a solution. The sine of this angle, right, the sine of that answer is negative 0.755. The sine of 11.771. Now, this is rounded, so it'll be close to negative 0.755, but the sine of 11.711 radians is close to negative 0.755. Again, the only reason it's not exactly the same is because that answer was rounded, but you see how close it is? So right here I have 6 solutions rounded to 3 decimal places. Now we're not asked for 6 solutions, right? We're only asked for ones that are between 0 and 2 pi, right? We want the solutions that range from 0 to 2 pi. Now, and not including 2 pi. Now 2 pi is like 6.28 radians, right? Because pi is about 3.14. So if you look at all my solutions here, right, and really that's all that's happening here is you keep adding 2 pi, 6.2, about 6.28, keep adding 6.28, keep adding 6.28. You know, that's really what's happening with all these solutions. If you look at my solutions listed there, you know, the only ones that fall in this range are the 3.997 radians for theta and the 5.428. These are the only ones that actually fall in that range from 0 to 2 pi, right? The other ones over here, 10.280, 11.711, are too big. All the ones over here would be negative. They're too small. Okay, so just 3.997, 5.428. Oh, 427, that's the closest one. And 3.998, I guess, because they must have used, you know, negative 0.856 and then kept adding. So these are the closest two, right? 3.998 is basically 3.997, and then 5.427 is basically the 5.428. And those are the only two solutions I could find, you know, rounded to 3 decimal places or whatever, that are in the range that they want, right? In the interval from 0 to 2 pi. And again, please, you know, read. See, they rounded right away and then used that rounded value. That's how they got a little off of what I did, because I didn't use the rounded value. I used the inverse sign, you know, the whole thing. Okay. So, yeah. Hopefully watching me do that helps a little bit. Looking at the more instruction, reading these answer explanations. You know, hopefully all this stuff helps you out when you work on this on your own. These are a little trickier, I understand. There's a lot of calculator work. But hopefully seeing this, and I'll have one more video on this as well. Hopefully seeing a couple of these will help out. And thanks for watching.